give you 2 problems. Okay, this would be more like an extra credit sort of problem. Okay, so problem number 6. So what do we have? We got a long jump. It's leaving the ground at 28 degrees, and then it's going to travel 7.8 meters. So what is the takeoff speed? Okay, so what is the takeoff speed for this one? All right, again, the same setup. Okay, so we got the X and Y directions, and then boom, 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 we got the projectile motion. So what do we know? We want to know the initial velocity, so that's what we're trying to figure out. So from the information given, I want to know what the takeoff speed was in terms of miles per hour. Okay, so that's what we want. Okay, so they give us the angle. All right, so this angle is already given at 28 degrees, so I'm done with that. Also, we are given the distance that this guy travels on the X direction. All right, so this distance is given. And in terms of 7.8 meters, so we don't have to do any conversions. So what's the takeoff speed? Okay, guys, we don't have any conversions. Very good. All right, so this is what we're trying to figure out. So how do we do a problem like this? 28. All right, we want to figure out the takeoff speed. Okay, let me just clean this up. So obviously acceleration is 0, so we don't use that. Just get rid of that. This one is redundant. Okay, so I got 1, I got 2, 3, 4, and 5 formulas available to me. Okay, so what is the initial speed? Okay, so what I'm gonna do before I start, guys, this is what I'm looking for, and this comes in 2 flavors. All right, one flavor is gonna be, it's gonna have an X component. The other flavor is gonna have a Y component. Okay, so you can't get to this directly, but you can get to it through this, or you can get to it through that. Okay, so which means that this one is the X component. So let me just make that clear.
Would you do number 1?
Okay, so it's trial and error, so we'll just do the trial and error. Okay, so you want to do 1? We'll do 1 if that's the case, because it looks like I solved these problems ahead of time. I don't. This is a little bit more interesting. A natural way of doing it. Struggle, man. Okay, so because I can get to this, I know I can get to this through these. Okay, and the reason why I know that is because the X component of this is going to be the what is it? Is it the sine of that angle? So angle is given. And the Y component of the initial speed is going to be the cosine of that initial speed, cosine of the angle of that initial speed. So notice that from that, I can actually get to the right answer. All right, so I can get to these through only these 2 terms. Okay, so which one should we try? Okay, one suggestion is, hey, try this one. Okay, so I know the distance, and this is something I may be able to figure out, but I don't know time. So this one is actually promising. Okay, so that's promising because I'm thinking in my head that I can probably make this work. So I'll say, yeah, that's an option. Okay, what else is promising? Okay, so let's take a look at this. Okay, I don't know the final speed on the Y direction, so this is not okay. There's nothing going on here that I can use. Another one that looks like maybe useful is this one. I may be able to make that one work. Okay, the reason I'm saying that is because notice that this thing is going to go up and down. All right, so the time for it to travel this way is going to be the same as the amount of time it takes for it to go up and down. All right, so those 2 are the ones that I can use. All right, guys, it's trial and error at this point. Okay, so I want you to see us struggle in solving a problem. All right, let's check this. Let's start off with this one, and then let's check to see how far we can go. If it doesn't work, then to hell with it, we'll try something else. All right, so that's my starting point. All right, so I'm gonna pick this one. All right, so initial speed along the X direction times time. All right, and I know that the initial speed on the X direction, okay, immediately I'm gonna go, oh, I can express this in terms of the initial speed that I want. So I'm just gonna do a back substitution immediately. All right, times time. Okay, and so what do I know in this one? Okay, so X is known, so this checks out, I'm good. This is what we were solving for. Okay, that's an unknown. This is known, so I'm happy with that. I don't know time, but you know what, guys? I can figure out time. I can figure out time from here, employing the same trick that we employed before. So what is the final height here? it's going to be 0, right? So immediately I go, okay, so now I have a rough idea of what to do with this, because here's a formula that I used before that I may be able to use again. All right, so what do we know?
Wait, hold on. Is it sine or cosine?
Okay, so x component is going to be sine or cosine?
I thought it was v theta x equals v theta times cosine theta, right?
Okay, so which means
Yeah.
that it has to be, okay, guys, let's take a vote. Is it sine or cosine?
Cosine. Cosine.
Okay, good. Okay, so what
Cosine.
did you learn
Cosine.
from this? Okay, so these kind of mistakes can happen, especially if you are not paying attention. And it will happen to you as well on the test. Okay, if I see work though, I go, okay, so this guy knows what's going on, but obviously he wasn't paying attention. It's fine, it happens to everyone. Okay, so I don't usually penalize you as badly. Okay, with numbers, if you put in the numbers here, I can't really follow, but this is easy. All right, so those of you guys who noticed that it was supposed to be cosine, give yourselves 10 points for that one. So I'm glad you noticed it, because if you didn't, something else was going to happen, and I was gonna know immediately that I made a mistake. Okay, because something weird is going to happen. Okay, so what do we know? We know at the end of the motion. Okay, so when you go up and down, okay, it's going to be 0 here, so I know that much. So I made that 0. Okay, initially you're going up against gravity, so gravity is going to reduce your speed, so I'm going to end up using the negative. And at this point, instead of repeating all the algebra that I did before, okay, so let me just write this out. Okay, so we did the algebra before. So what I'm going to do is I'm just going to finish this up. Okay, so this was done before, guys. It's right here. All right, so you finish out the algebra, so this is what you get for t. And then boom, I'm going to just drop it in there. Okay, so let's go back. So we got x, initial speed, sine of the angle, and then just go blue.
Cosine of the angle, no?
Okay, and okay, today's not a good day. All right, give yourself 5 points for that. So this is the cosine of the angle. So we're still at the cosine of the angle, cosine of the angle. Okay, so for t, it's going to be 2VO divided by VO. This is the component of the initial speed on the y direction, and divided by g. Okay, so I'm gonna bleed into this area, so I'm gonna clean this up. Okay, so notice that you have this term here. All right, so that term is the same as this term. Okay, now we have to do a substitution. Okay, so what do we have? So you will have x, you have VO times the cosine of the angle, and then I'm gonna pull the 2 up front. And then you have VO again, this time the sine of the angle. This is when I would have noticed that one of them is, you can't get sine squared for this one. And everything is going to be divided by g. Okay, so let me ask you this question. All right, so you have 2 cosine of this angle and sine of this angle. All right, so what is that? What kind of a trig identity is that, if you know that? Okay, so VO and VO will give you a square. And then so you have sine of the angle times the cosine of the angle divided by g. All right, so 2 sine of the angle times the cosine of the angle. Okay, so what is it? All right, if you don't
Is
remember
it a
it.
double angle identity?
All right, absolutely. Give yourself 10 points for that one. I mean, some people remember it, most people don't. Okay, so this is going to be, what is it, 2 times sine of the angle. Okay, so 2 times sine of the angle. So this 2 times sine of the angle times the cosine of the angle is going to be 2 times the sine of the angle. Bam. I'm almost done. So x is going to be, it's going to be, what is it? It's going to be VO times sine of double the initial angle divided by g. Now, magically you isolate that. Okay, and when you do, I should probably show work. All right, so we're almost done. All right, so get rid of VO. Okay, I don't want to get rid of VO. What the hell is happening? Can't get rid of, what are we looking for? We're looking for the initial speed. Okay, so get rid of the angle, double the angle, and then get rid of G, and then we're done. All right, so the final answer is going to look like this. So it's going to be x times G divided by 2 times the sine of the angle. The sine of the, twice the sine of the angle.
I have a question.
Okay, hold on. I'm just, okay, so before you have a question, okay, somebody just give me the answer. All right, so plug the numbers in. And then just give me the answer in terms of meters per second.
83.01 meters per second.
83 meters per second. Okay, let me get a verification on this one. No, that can't be.
Wouldn't
No.
it be VO, or wouldn't it be squared because you had the
Damn,
V,
you
the
found it.
cosine and
You
sine?
give yourself 5 points for that one. Absolutely, yes. I mentioned it here. They're squared, and then I forgot to put it in. Okay, so it's getting real late. It started to show. Yes, it is squared. Give yourself 10 points for that one. It is squared. This is squared. So which means that you have to take the square root of this. Okay, so what's the square root of 83 meters per second if that's the case?
9.11.
Okay, now it looks to me like it's reasonable. 9.1 meters per second. Okay, so what is this in terms of miles per hour? Okay, so do a conversion to miles per hour. No. Okay, guys, something like this would be good for an extra credit problem. Too much work. Okay, so 2.1 in terms of miles per hour, what would you get?
20.38.
Okay, 20.38. Okay, roughly 20 miles per hour. So give yourself 5 points. All right, guys, this guy is a long jumper. This is actually fairly realistic. I would say 7.5 meters. Notice that these guys are running almost as fast as the sprinters. Okay, sprinters are around 22, 23 miles per hour, real good ones, but these guys are up there. Okay, these guys run pretty damn fast. This is good. Okay, so this is a lot of work. Okay, and notice that you can't put numbers into something like that. It's just that you won't be able to solve it. And even while you're solving it this way, if you're not paying attention, obviously the mistakes start to creep in. But let's pretend that this is what you turn in, and you forgot to do this. It's not a big deal. That's to be expected. It's a test. You get nervous, this and that. Here, I'm getting real tired because I don't know, it's like 9 o'clock. And I've been doing this ever since 8 in the morning. All right. And notice that the number that you come up with is, this is not that, I mean, just putting in the number, this is only 1% of the work. 99% of the work is right here. And it's not even the math, which is the difficult part. It's just figuring out how to solve this problem. Okay. So that comes with practice. Okay. Somebody had a question and I said, let's get back to it. So what was the question?
That was me. I was going to ask if it was the initial velocity squared.
Don't ask, just tell me. I'm going to give you 10 points for that one. Okay, so if you see a mistake, see something, say something, airport rules in effect, or else this turns into an explosive mistake. Because as soon as we got like 83 meters per second, I say, no, something is wrong. Okay, so things usually, if there's a mistake, you get a sense for it. That's the reason why the final interpretation is important. 20 miles per hour is reasonable for these athletes, but it shouldn't be 120 miles per hour. And immediately I knew we were supposed to have sines and cosines somewhere. It was fairly obvious, that's from experience. I would have known that I goofed this up at some point, but I wasn't really paying attention. I'm glad that some of you guys were.
Wow.
So no one is perfect, guys. All right, so don't feel bad if you make mistakes. Okay, I'll be understanding, provided that I can see the work. I mean, as long as you are picking the right formulas, this and that, sometimes things go to hell, so I get that. Okay, so moving forward.